Oftentimes, we are able to solve equations in a variety of ways. One of the most popular ways to solve an equation is algebraically, but we are also able to solve it graphically and numerically as well. In this lesson, we are going to focus on a couple non-linear equations to solve in a variety of ways. The first one we'll start with is a quadratic equation. It is quadratic because the highest exponent in that equation is a 2. One way to solve this equation would be to set it equal to 0 and use the quadratic formula to solve it, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. With a being this positive 2 value, b being negative 3, and your c value being equal to negative 2. Another way to solve this equation is to graph it and find the x-intercepts of the graph. The x-intercepts and the solutions are synonyms, because when I set this function equal to 0 and solve it algebraically, that would also be finding the zeros of the graph. So as I move to my graphing of this quadratic equation, you can see that this quadratic equation creates a parabola like all quadratics. And when I zoom in on this equation and I find the zeros of that function, they appear to be negative 1/2 and positive 2. Another way that I'm able to solve this equation would be to solve it by factoring. So I once again can set this quadratic equation equal to 0 and then factor this quadratic trinomial. One way to factor this quadratic trinomial would be to look for factors of 4 because of that coefficient that subtract to be 3. So factors of 4 that subtract to be 3 would be 4 and 1. I'm going to simply copy down the first term and the last term, and then I'm going to rewrite the middle term as 2 terms using those factors of 4 that subtract to be 3. Then I also need to create a value when I combine those two like terms that is equal to negative 3x. So that is going to be negative 4x plus x. My next step in factoring would be to split this in 2 groups and factor by grouping since I have 4 terms. Taking out the greatest common factor from both leaves me with 2x times the quantity of x minus 2 and positive 1 times the quantity of x minus 2, all equal to 0. My last step in this factoring by grouping is to rewrite it as a product of 2 binomials. So the 2 greatest common factors, 2x plus 1, and the 2 binomials that match up being x minus 2. Now I have a product that is equal to 0. We all know that if I have a product that is equal to 0, that means that x or y must be equal to 0 in order to have a product equal to 0. So looking at this factored form, that must mean that 2x plus 1 must equal 0, or x minus 2 must equal 0. Then I need to solve each of those by using inverse operations, which leaves me with those same 2 solutions of negative 1/2 and positive 2. The quadratic formula will also give me those solutions of negative 1/2 and positive 2. The next nonlinear equation that we are going to solve is an absolute value function. One possible way to solve this by graphing would be that in this case, I'm not wanting to know the zeros of the function because it says that my function should be equal to 6. So I can set 2 equations in my graphing calculator, one where I have that function of the absolute value of 2x minus 1, and another where I have the function where y equals 6, because I now want to know where will this function be equal to 6 and not 0. So that's why I'm going to look at the intersection points of these 2 functions, and that will tell me where on the absolute value function that it is equal to positive 6. So one of them is being negative 2.5, and in another 3.5.